Hello, everyone. In this part of our study on confidence intervals, we are going to first discuss some terminologies we use for confidence intervals, and then we will learn how to represent confidence intervals on a standard normal curve. And after that, we will discuss the logic that we use to find the endpoints of an interval. Before we go into learning about how to find confidence intervals in statistics, let's get familiar with a terminology called a point estimate. Now, the definition here says a point estimate of a parameter is the value of a statistic used to estimate the parameter. Let's stop here a little bit to recall what parameter is versus what a statistic is. A parameter refers to population measurements. Therefore, the population mean mu or the population standard deviation sigma, they are all considered to be parameters, whereas a statistic refers to sample measurements. So X bar, which is sample mean, or S, which is the sample standard deviation, are all considered to be statistics. Now, in inferential studies, we use our sample measurements to estimate the population measurements, right? So we will use a particular statistic obtained from our sample study to draw inferences, draw conclusions on the population measurements, perhaps the population mean on the parameter. So that particular measure of the sample study, and most often it's going to be the sample mean for purposes of our course, that value that we are using as the basis of estimating a population measure is going to be called the point estimate. So when we build our confidence interval, we will build it around our sample mean, and that particular sample mean is also referred to as the point estimate, right? We are going to now go over the formal definitions of confidence interval, the confidence level, and what's called the confidence interval estimate. Now, the confidence interval is defined as an interval of numbers obtained from a point estimate of a parameter. It means that the confidence interval is the actual interval that we create around our sample mean within which we expect the population mean to fall. All right, so that's what the confidence interval is, and it is generally denoted in short form as CI. The confidence level is the confidence we have that the parameter lies in the confidence interval, that is, that the confidence interval contains the parameter. So when we talk about the confidence level, we imply how much confidence we have that the population mean, our estimate, will fall within the interval that we have created and not outside that interval. And the confidence interval estimate is the confidence interval and the confidence level and the estimate we come up with together. Now here we have an example of several confidence intervals obtained from different sample studies from the same population mean. So the study was for the mean price of all new mobile homes, each based on a sample of 36 new mobile homes. So that means the sample size of each sample was 36, and they came up with all possible samples from the same population, and there were 25 samples that could be created, and then they found the sample means for each of the samples. And as you see, the sample means will differ for each sample because there are different mobile homes included in each sample. correct? So X bar, the sample mean, is different for different sample studies naturally. And then once we have the sample means, we can go ahead and build a confidence interval of a certain percentage. Here they have used the 95% confidence interval, and we have different interval endpoints. In the first case, it's 63.05 to 67.85. In the second case, it starts from 61.81 to 66.61, and they are all built around the sample mean we found for that sample. And then finally, once we have intervals, we can go and check if the population mean falls within the confidence interval we created. All right, now keep in mind, from a previous chapter, we had learned that the mean of all the sample means is always going to be equal to the population mean. So when they found the mean of all these sample means, they came up with a value of 65, which is also the population mean. And then we check if that 65 falls within the interval or not. So we see in most cases the interval contains 65. The population mean will be contained within the interval, except in one case in sample 15, where the interval starts from 65.33 to 70.13. So it's a narrow miss. Our population mean is 65, but our interval begins from 65.33. All right. So that's what this example is trying to explain. And from here on, we will go into an understanding of what this 95% confidence interval or the 99% confidence interval or the 90% confidence interval means. It essentially tells us how wide our interval is going to be. So we'll go into more details in the next few slides to understand that. Now, a confidence interval is qualified by a percentage value. It could be a 90% confidence interval or a 95% interval or a 99% interval or any other percentage value for that matter. Now, what does that mean? The percentage value tells us how wide our interval is going to be. Higher the percentage, wider is our interval. Now let's look at this diagram here. We have a picture of a standard normal curve, and we see that there is a shaded area, there's a shaded region under the curve, and that region spans a width along this horizontal line above which the curve appears. All right, now these endpoints that the region marks represents the endpoints of the confidence interval. All right. And the endpoints cover an area equivalent to 0.95. That value is derived from the percentage confidence interval we are using to build our confidence interval. All right, if you divide 95% by 100, we will come up with 0.95. Keep in mind that the area under the curve has to be a value between 0 and 1 because the total area under the curve is equal to 1. All right, so another way of interpreting this is the probability that the population mean is going to fall within the interval we build is 0.95. This 0.95 represents the probability that the population mean will be contained within the interval that we build. All right, so 0.95 is the probability that it'll lie within that interval. Therefore, what is the probability that the population mean may not be contained within our confidence interval? That's the unbounded region on either side of the curve, correct? These white areas. They are very small, but that's the probability that the population mean will not fall within that interval, will be outside that interval. So that probability, that unbounded region, will have an area which is equal to 0.05. How come? Because the total area under the curve is 1, and the bounded region, the shaded region, has an area of 0.95. Therefore, the unshaded region will be 1 minus whatever the bounded region is, 0.95. That would give us the value of alpha. Now, alpha is the sum total of the unbounded region. In order to find the area on each end of the curve, we have to divide alpha by 2. Alpha has to be divided by 2 evenly, and we know it's going to be equally divided because this is a symmetrical curve, and our x bar, the mean, lies at the center of the curve, and the margin of error that we give on each side are going to be equal. The margin will be equal on each side, right? Therefore, the area, unbounded area on each side, will also be equal. All right, that's why we divided alpha by 2 to get the area on each side. Now that we know the area on the extreme left-hand side, we can find a corresponding z-value whose area to the left is 0.025. Likewise, we can find the z-value whose area to the right is 0.025. So, on the left-hand side, we will have a negative z-value corresponding to an area of 0.025. On the right-hand side, it's going to be a positive z-value whose area to the right is 0.025. All right? And once we have our z-values, we can convert it to x values. We can find the corresponding x values using the formula for z-values for sample means. All right, now in inferential studies, we are working with sample means and not individual observations. And the formula for the z-value of sample means is x bar minus mu divided by sigma divided by square root over n, sigma over square root over n. And if we can find our z-values at both ends of our interval using a table or using a calculator, we will find our z-values. We will be given a value of the mean, a value of the population standard deviation, and a sample size. We can plug in the values for each of these variables, and then we can solve for x bar and come up with the endpoints of our interval. So in the next slide, we are going to go through a well laid out process of finding confidence intervals when the population standard deviation is known. And then we are going to go through some examples of finding confidence intervals. And also we have to cover a few more concepts about confidence intervals. All right.